All right, strap yourselves in because today we're diving headfirst into some seriously mind-bending stuff. The many worlds interpretation of quantum mechanics.
Oh, yeah, you know the one where every time you make a quantum measurement, a whole new universe pops up?
But exactly. We're talking parallel worlds, alternate realities, all that jazz.
It's one of those concepts that really captures the imagination, although it often gets twisted a bit in popular culture.
For sure. So today we'll be using excerpts from the Stanford Encyclopedia of Philosophy's entry on the MWI as our guide.
Right, so we're not messing around with sci-fi tropes here. This is some serious philosophical territory.
Absolutely. And we've got some big questions to tackle, like what exactly does a world even mean in this interpretation?
Yeah, and how does our own experience fit into this grand multiverse picture?
And maybe the biggest one of all, how can we even talk about probability when every outcome seemingly happens in some other world?
It's a truly fascinating mix of physics and philosophy, maybe even some of the most intriguing questions in science, really.
Totally. So let's start with the basics. What exactly is a world in the many worlds interpretation? It's not like a bunch of new planets are suddenly appearing, right?
Not quite. It's not like suddenly, poof, there's another Earth. Think of it more like this. A world in MWI is a complete, consistent description of every macroscopic object in a definite classical state.
Okay, so we're talking stars, trees, cities, even like that coffee mug on my desk right now, all in a specific arrangement.
Exactly. And it's crucial to remember that MWI sees all these worlds within a single universe.
Okay, so not a bunch of separate universes floating around, but more like branches splitting off from a single tree trunk.
Yeah, a good analogy. It's not different physical spaces, but rather different configurations of the same fundamental stuff.
So in one world, my coffee mug is full, in another it's empty, that kind of thing.
Precisely. And that leads to another interesting question. How does time work in this framework?
Right, because if it's all one big interconnected universe, how do these different nows relate to each other?
Well, here's where it gets even more interesting. Each world, at a specific moment in time, has a unique past, kind of like a family tree. It all goes back to a single ancestor.
So like a shared history for everything up to a certain point.
Exactly. But then, as you move towards the future, the branches start to split, creating multiple potential futures for every world based on the outcomes of quantum events.
So every time something happens on a quantum level, the timeline forks and a new reality splits off from the old one.
Yeah, you could say that. It's like a constant branching out of possibilities.
Okay, I think I'm starting to get the picture. But where do we fit into all of this? Are there like multiple me's running around in these different branches?
That question gets right to the heart of personal identity in the MWI. The interpretation defines you as the complete physical description of your body and brain at a given moment.
So, to put it simply, there could be many versions of me out there, each one experiencing a different outcome of some quantum event.
Exactly. One version of you might win the lottery, another might decide to become a professional mime. You get the idea.
Wow, that's a lot to take in. But how does that square with my memory of a single, consistent past?
Well, all those past versions of you, they've all converged on this particular moment, the now that you're experiencing.
So my past is unique. It's the same for all those different branches. It's just the future that keeps splitting off in different directions.
Precisely. Your past is a single thread, but your future is a whole tapestry of possibilities.
It's both exciting and a little terrifying, like
Yeah.
standing at a crossroads with infinite paths ahead. But how does this idea of branching worlds actually connect to the underlying quantum state of the universe?
Ah, well, that's where the universal wave function comes into play. Think of it as a massive mathematical description that encompasses all those possible worlds, every potential configuration of reality.
So it's like a giant blueprint that contains the instructions for building every possible version of the universe.
Yeah, kind of. It's like a cosmic cookbook with every recipe imaginable.
I like that analogy. But if everything is contained within this wave function, this blueprint, why don't we experience the world as like this blurry mess of every possibility all at once?
That's where the concept of decoherence comes in. It's the process that separates different parts of the wave function representing those distinct worlds. They stop interacting with each other.
So those different possibilities become isolated, solidifying into separate, well-defined realities.
Precisely. And that's what leads to the apparent stability of our own world, making things like my chair or your coffee mug seem solid and consistent.
So the universe is constantly choosing specific recipes from that cosmic cookbook, making our reality solid and stable for us to experience.
You got it. Though it's important to understand that connecting our individual experiences to this vast wave function is something we can only do for all practical purposes, you know? We can't
Mm.
account for literally every particle. But the MWI framework does give us a pretty good explanation for why things happen the way they do, even the really weird stuff we see in quantum experiments.
Right, I'm following so far. So we've got these branching worlds, each one a separate configuration of reality within one big universe, all connected by this universal wave function. But if all these worlds are out there coexisting, does that mean some are, like, bigger or more real than others?
That's a fantastic question, and it brings us to the concept of a world's measure of existence. But now, this doesn't mean that some worlds are physically larger.
Right, so we're not talking about size in the traditional sense.
Exactly. Instead, it refers to their relative presence within the universal wave function.
So it's more like some worlds have a stronger signal, a bigger footprint in the overall scheme of things.
You got it. And this measure of existence, which is tied to something called the squared amplitude of the quantum state that represents a world, this is going to be absolutely crucial when we get to the even more mind-boggling question of probability in the MWI. But that's a deep dive for another time. Picking up right where we left off, this idea of a world's measure of existence, it's really key to understanding how the MWI tackles the whole concept of probability.
Yeah, that's the part that's been really tripping me up. I mean, if every possible outcome of a quantum event actually happens in some world, how can we even talk about something being more or less likely?
It's a question that gets right to the heart of things. It seems like if everything happens somewhere, the idea of probability just kind of goes out the window, right?
Exactly. It's like flipping a coin and saying, well, heads happen somewhere and tails happen somewhere else, so who cares?
And that's where things get really interesting. The MWI doesn't just discard probability. It offers a really unique perspective on how it emerges within this deterministic multiverse. And the key to understanding this is something called, are you ready for it? Post-measurement uncertainty.
Okay, I'm intrigued. Post-measurement uncertainty. That's a mouthful. How does that work exactly?
Let's try a thought experiment to illustrate this. Imagine you're given a sleeping pill right before a quantum measurement takes place. This measurement could be something as simple as, say, the flip of a quantum coin.
Okay, I'm with you so far.
Now, while you're asleep, the outcome of this coin flip determines whether you wake up in, let's say, room A or room B.
So we've got two worlds branching off, one where the coin lands heads, I wake up in room A, and another where it lands tails, and I'm in room B.
Got it. Precisely. Now imagine you wake up, but you haven't opened your eyes yet, and someone asks you, what's the probability that you're in room A? What would you say?
Honestly, I'd have no clue. It could be either one, right?
Mhm.
50-50 chance.
Exactly. And here's the crucial point. Even though the outcome of that coin flip has already been determined, you're still in a state of subjective ignorance. You simply don't know the outcome, so from your perspective, there's a very real sense of probability.
So even though both outcomes exist in their own separate worlds, my experience within each one creates that sense of probability. The me in room A doesn't know there's another me in room B, and vice versa.
Exactly. It's like each of those versions of you is living their own reality, unaware of the other possibilities. Now, the MWI takes this idea even further with what it calls the probability postulate. It essentially says that an observer should set their subjective probability of a particular outcome in proportion to the total measure of existence of all the worlds where that outcome occurs.
Hold on. So the worlds with a larger measure of existence, the ones that are more prominent in the universal wave function, are the ones we're more likely to find ourselves in.
You got it. It's like, imagine we have a bunch of light bulbs all switched on, but some are much brighter than others. The probability postulate says that we're more likely to experience those brighter worlds, the ones with a bigger presence in the wave function.
That's a great way to visualize it. So even though all those light bulbs are technically on, the brighter ones are the ones we're actually going to see.
Exactly. And this ties into another really important concept called the behavior principle. This principle suggests that we should care more about the versions of ourselves in those brighter worlds, the ones with the larger measure of existence.
So it's like, even if there are countless versions of me out there, I should be more worried about the one who's, facing a giant asteroid in a world with a huge measure of existence than the one who just won the lottery in a world with a tiny measure.
You got it. It's a way of understanding why we experience probability and how it can actually guide our actions, even in a multiverse where Technically, everything happens somewhere, and we're just scratching the surface here. There are other fascinating approaches to deriving this probability postulate, like Deutsch's decision theoretic framework and Zurich's work on invariance, but those are deep dives for another time.
My head is already spinning, but in a good way. It's amazing how the MWI manages to address all these seemingly paradoxical elements of quantum mechanics. But let's be honest, this whole idea of an infinite number of worlds, it's a lot to swallow. Doesn't that kind of violate Occam's razor? The idea that the simplest explanation is usually the best.
That's a common critique, for sure. But proponents of the MWI argue that in terms of the fundamental physical law, it's actually more parsimonious. Because think about it, the MWI gets rid of the need for a separate collapse postulate. That's the kind of ad hoc rule that forces the wave function to collapse into a single outcome during a measurement.
So instead of adding this extra rule to the game, the MWI just lets the Schrödinger equation play out naturally, leading to the creation of those branching worlds.
Precisely. Plus, that whole collapse postulate, it's pretty problematic. It introduces randomness and action at a distance concepts that don't really fit with our understanding of how physics is supposed to work. But the MWI avoids all that by sticking with the elegant determinism of the Schrödinger equation.
Okay, that makes sense. But even if we accept that the MWI is simpler when it comes to the laws of physics, isn't there still something arbitrary about how we divide the universe into these separate worlds? I mean, who decides where one world ends and another begins?
That's the preferred basis problem, and it's a very valid point. But as we talked about earlier, decoherence plays a big role here. The fact that macroscopic objects tend to stay put, that they maintain their localized states, provides a natural and physically grounded basis for defining these worlds.
So it's not like physicists are just randomly drawing lines in the sand, saying this is a world, that's another world. The divisions are based on how the universe actually behaves, guided by that principle of decoherence.
Precisely. You see, the small value of Planck's constant means that these macroscopic objects can hold on to their localized states for long periods, and that's what gives us this experience of stable, persistent worlds.
All right, that helps to clarify things.
Yeah.
But I still have this kind of philosophical hang-up. We keep talking about this wave function that exists in this abstract, multidimensional configuration space.
Yeah.
But how does that connect to our everyday experience of living in a three-dimensional world? It feels like there's a disconnect between the math and our lived reality.
That's a really insightful observation. You're touching on a very important debate in the interpretation of quantum mechanics. Some argue that the wave function by itself isn't enough, that we need some extra primitive ontology that exists in space-time to really ground our experiences.
So like some kind of tangible stuff, some fundamental building blocks of reality that the wave function is merely describing.
Yeah, that's one way to look at it. But proponents of the MWI often push back on that idea. They say, no, the wave function is enough. They argue that we can actually understand our three-dimensional experience by examining something called the expectation values of particle densities in space-time.
So by analyzing how those particles are distributed across those different branches of reality, we can kind of construct a picture of a consistent three-dimensional world. It's like even though the individual dots in a pointless painting are all scattered, they still come together to form a recognizable image when you step back.
That's an excellent analogy. Those individual worlds, each one with its unique arrangement of particles, contribute to this emergent three-dimensionality that matches what we experience.
That's a great way to visualize it. But even if we accept that the MWI can account for our three-dimensional experience, there are still those lingering philosophical questions, like if every choice we make leads to a new world where we made a different choice, doesn't that undermine the very idea of free will?
Now that is a deep question, and it gets to the very core of how the MWI challenges our basic understanding of ourselves and the choices we make. Some people argue that the MWI actually points towards something called superdeterminism. That's the idea that everything, including our choices, is already predetermined from the very beginning. So in that view, free will would just be an illusion.
That's a pretty bleak outlook, isn't it? So you're saying even though it feels like I'm making real choices, those choices were already baked into the universe from the get-go.
That's the superdeterminist interpretation, yes. But others say, hold on, free will is still compatible with the MWI. They argue that even if every possible choice plays out in some world, that doesn't take away from the fact that we, within our own individual worlds, still experience the process of making choices. We still feel the weight of those decisions.
So it's like, even though there might be a world out there where I'm a rock star instead of a podcast host, the fact that I'm sitting here talking about quantum mechanics makes my choices feel real and important in my own experience.
Exactly. The MWI doesn't necessarily eliminate that subjective feeling of making choices. It just challenges our assumptions about what those choices ultimately mean in the grand scheme of things.
Okay, that's slightly more comforting. But it still makes you wonder about the implications. I mean, if all these other versions of me are out there living out every possible path, does that change how I see my own life? Do my struggles, my achievements, do they feel less significant?
Now, that is a very personal question. And it gets to the heart of how the MWI can really change our whole perspective on life. Some people find this idea of infinite parallel selves incredibly comforting. It's a reminder that there's always another chance, another path. But for others, it's unsettling. It makes them think about the vastness of the universe and how insignificant we might be in the grand scheme of things.
It's definitely a lot to process. But, thinking about all those different versions of me, living out those alternate realities, it makes you wonder if we could somehow peek into those other worlds, what would we learn about ourselves? Would seeing those other paths change how we live our lives in this one?
Now, that is a question that philosophers and science fiction writers have been pondering for years. It really gets to the core of identity, choice, and the meaning we find in life. If we could actually see those paths not taken, those choices made differently, how would we feel? Regret, relief, maybe even a sense of validation knowing that everything played out the way it was supposed to.
It's almost too much to think about.
Hmm.
But I think even just asking those questions shows the power of the many worlds interpretation. It pushes us to expand our understanding of what's possible and to rethink our place in this amazing and mysterious universe.
Okay, but even after all of this discussion, there's this tiny part of me that still wonders if the many worlds interpretation is, well, just a really cool thought experiment. Is there, any way to actually test this, to find any evidence for these other worlds?
That's the million-dollar question. And the answer, unfortunately, is not so simple. You see, the MWI, at its core, it's inherently deterministic. There's no randomness built in.
So there's no element of chance, no dice being rolled. Exactly. And that makes it incredibly difficult to design experiments that could definitively prove or disprove the theory.
So we're essentially stuck observing our little corner of the multiverse with no way to peek into these other realities.
Seems that way, at least for now. But that hasn't stopped physicists from brainstorming ways we might catch a glimpse of those parallel worlds. Some have proposed thought experiments that involve reversing quantum measurements.
Reversing, like hitting rewind on the universe.
Yeah, kind of. The idea is to look for signs of interference between those different worlds, like seeing if they somehow bleed into each other.
So it's like trying to rewind a cosmic movie and see if different storylines start to overlap. Pretty wild.
It is. The problem is that these experiments would require technology that's, well, light years ahead of where we are now. We're talking about perfect control and manipulation of quantum systems.
So for the time being, the MWI remains this tantalizing theoretical idea. Fascinating to think about, fun to debate, but not something we can definitively prove.
That's a fair assessment, yeah. But even if it stays in the realm of theoretical physics, the MWI has had a huge impact on how we think about quantum mechanics. It's led to all sorts of discussions about, well, the nature of reality itself.
It certainly sparked a lot of discussion in my head. Thinking about all those other versions of me out there, all those different lives being lived, it makes you wonder, if we could somehow look into those other worlds, what would we see? Would it change how we live our lives in this one?
That's a profound question, and it's one that both philosophers and science fiction writers have been exploring for decades. It really gets to the heart of identity, choice, the meaning of life. If we could see those paths not taken, the choices made differently, how would we feel? Regret, relief, a sense of maybe cosmic validation?
It's hard to even wrap your head around. But even just asking these questions, it speaks to the power of the many worlds interpretation. It challenges us to think bigger, to question everything we thought we knew about reality and our place in it.
I couldn't agree more. The MWI isn't just about equations and probabilities. It's about grappling with the biggest mysteries of existence and trying to understand a reality that's far stranger and more wonderful than we ever imagined.
Well said. I think that about wraps up our deep dive into the many worlds interpretation. It's been an incredible journey through branching realities, quantum paradoxes, and all sorts of mind-bending philosophical quandaries.
It's been a pleasure exploring these ideas with you. And to everyone listening, I encourage you to keep thinking about the MWI. Keep asking those big questions. Who knows, maybe someday we'll have the tools to actually look into those other worlds and see what lies beyond our own reality.
And until then, we'll keep exploring those mysteries one deep dive at a time. Thanks for joining us.